Welcome to this unit where I'm going to talk about how we can actually find out from the text of an exercise in business mathematics with which of the different topics the exercise will be about. So what you actually have to do in these exercises. So it's basically just an answer to the question, how do I know what to do? With an addition of for the specific exercises. So for this, let's start by having a look at some specific keywords, which gives us a first clue in which field to look more closely. That's the first part. Could be that it directly says, please calculate derivatives of the following functions. Well, that's relatively straightforward. However, there are different ways how to determine which derivatives to act or which formula for derivatives to actually use. So that's why in the next slide, we're taking a more closer look to this topic. So which formula to use in which case. Also relatively straightforward is if you have exercises with regards to calculating something with matrices, like adding two matrices, multiplying two matrices, stuff like this. So in this case, you can directly see that the exercise is about this topic if you just saw one or see one of the matrices there, and then the corresponding operations. This also is true for the next topic. However, here you might also have a problem with considering where's actually the difference between the pure matrix exercises and the exercises with regards to linear systems of equations, because those usually are also given with a matrix and a vector. But they are written down in the specific version where you have like the matrix, then you have the vector with the variables you're looking for, then equal to, and then the right side. It's like the typical style of writing down a linear system of equations. Whereas with matrices, you could have any type of relation. So usually there the matrices are also given one after another. With the linear system of equation, you have the one version of writing this down if you write this down mathematically. The alternative could be that the linear system of equation is described via some kind of text. And you first have to translate the text into mathematical equations, and then the mathematical equations into the matrix vector representation. So this could also be the case. This would be a bit more trickier. However, in most cases, it's directly given mathematically. Well, while with the normal matrices, you can use the typical approaches for matrix addition, matrix multiplication. For linear systems of equations, there are also different approaches on how to solve them. The most straightforward approach would be the Gauss algorithm. So that's the recommendation whenever you see it's a linear system of equation, or it's some kind of text which can be interpreted as linear functions, then use the Gauss algorithm to solve the system of equations. And well, with matrices and linear systems of equations, we finished the whole block of linear algebra. However, when we talk about calculus, we have the derivatives and something which results from the derivatives. That's finding extrema of a function. That's actually the difference for the next two parts. We can either have one function alone with one or two or more variables. Then if we have this situation, so only the function, task, calculate extrema, calculate minima or maxima, then we just go about this the way we know for one variable. So first derivatives, second derivatives, then set the first derivatives equal to 0, solve for the variables, then insert them in the second derivative and decide if it's maximum, minimum, or cell point. Well, that's relatively straightforward, but it could also be the case that you're actually given two or more functions. So usually then it says calculate the extrema of function so and so under the constraints or while observing the restriction, the condition so and so. So whenever you have some kind of constraint, some kind of equation, some kind of function which acts as a constraint, and you have a function where you should find extremer of, this means you have to use Lagrange multipliers. It's relatively similar to the normal unrestricted case with only normal function, because the only thing you do is you start by building a Lagrange function. Lagrange function, that's simply the original function plus lambda times the condition. Then plus a second lambda times the second condition, and so forth. And then you just consider the Lagrange function as you did your original function for extremas. So you take the first derivatives, set them equal to 0, and solve for the corresponding variables. An easy way to go here as a first step in this context would be to start by solving the different equations for the parameter lambda. So first get rid of all the lambda parameters and then try to solve for the variables which are of interest to you. Okay, so far for the calculus part. So we have calculus, we have linear algebra, and we have the third part, which is business mathematics. With business mathematics, you can identify problems like this, as in they usually describe some kind of practical topic, some kind of, let's call this small case study, and it's usually related in some way with interest rates. So whenever you read like a practical problem and there's something about interest rates, that's where they differentiate from a text on linear equations, linear system of equations, it's related to interest, to saving money, investing money, stuff like this. And well, there's a lot of different situations in this context as well. So for this, we also take a more deeper look in the second to next slide. But before, as I said, let's first start with derivatives and have a much closer look on derivatives. That's actually here in the second slide. As I said, we work with derivatives. And well, if we have a function, we can always split this up in two functions if different parts are divided by an add sign or a minus sign. So if this is the case, like imagine you have a function x squared plus exponential function of x, then you can just separate the two parts. First the x squared, then for a second function, the exponential function. Derive each of the two functions separately, and then simply add their derivatives up again to get your final derivative. Well, that's relatively easy and straightforward. But this only works if you have a plus or minus between two functions. If you have a multiplication sign between two functions, so if you don't have x squared plus exponential function, but x squared times exponential function, that's where you need the so-called product rule. So that's one function times another function. Well, if we can multiply them, we can also divide them. So if you have one function divided by another function, or in other words, you see a fraction with a functional part in the numerator, functional part in the denominator, this means you should use the quotient rule. However, this only holds true if it's not a very simple expression, like 1 divided by x, 1 divided by x to the power of 2, because in this case, you could reformulate this. For example, 1 divided by x to the power of 2 would just be x to the power of minus 2. This makes it a bit more simpler to work in this way. This also holds true if you have a root function. So basically, a simple root function where below the root is just an x. So if you have square root of x, you could write this as x to the power of 1/2. If you have the third root of x squared, you can write this as x to the power of 2/3. Making this again relatively easy to be derived. However, if the root contains something else, so a more complex expression is under the root, then you need the so-called chain rule, which generalizes to one function is inserted into another function, situated inside another function. So for example, you have the square root of x as one function, and you have 1 minus x squared as another function. So if you take the square root of 1 minus x squared, that's actually one function inserted in another. That's the same as if you take the logarithm of, let's say, 1 plus the exponential function. That's also 1 plus the exponential function is one function, and this is inserted into the logarithm. So that's how you can detect where to use the chain rule. That's then all there is. You can combine two functions with plus minus, multiplication, division, or insert one function into another. And only in some very rare cases can you make it easier by just getting rid of roots or fractions. But this is not usually the case. So okay, that's basically all the different aspects you can come across for derivatives. So this then concludes the second part, this bit more in-depth discussion on how to find the rule you actually need for getting a derivative. And well, final comment in this regard, what if actually I have three functions which are multiplied with each other? Well, in this case, just work step by step. First, derivative of one part, keep the other two as they are, then consider the other twos. So it's basically using the product rule twice. If you have a product which is inserted into another function, well, do the same thing. First use the chain rule, then use the product rule. So it's just one step after another. Okay, so as I said, this concludes the part on derivatives. We only have one part left, which is the business mathematics part. And here, well, as I said, usually it's some kind of cases. Well, the question is, what is the case all about? So the first thing could be that someone is saving money on a regular monthly basis. Because if you just have one payment, you can just use the simple formula for compound interest. That's relatively easy and straightforward, but this is only one payment. If you have more payments, regular as to when they happen and regular in their size, then you can switch to the whole chapter on annuities, all the formulas in regard to annuities. More or less, this is then the up-payment part. The exact opposite of this is more or less you do not save money, you get a loan, and then you have to pay back the loan. And again, you're going to do this with a regular monthly payment. That's then what we talk about in the context of amortization. So you want to know, for example, what is the monthly rate if you only know how long you have to pay for this, or you want to pay for this. Okay, and we can also use the formulas from the amortization part in a slightly different context when, for example, we save up a certain amount of money and then we want to take out a specific amount of money out of our account. And a question could be, for example, how long does this actually last? So this is also tackled by the formulas with regard to amortization. It's slightly different from the consideration, but it's basically the same idea. Okay, so that's the first part. Annuities, amortization. You save money, you pay back a loan, or more or less you pay out your own investment. So it's like you're giving a credit to the bank and the bank is paying back this loan. That's more or less you save money and you get money each month. Okay, but then there's a, let's call this third or fourth part, which is investment valuation. This always occurs if you have a number of options which need to be compared. In usually most of the cases, what you do is just calculate the net present values of each of the options, of the cash flows associated with these options, and then compare them. Well, if you can compare the cash flows of different options, you can also use the same technique, same idea of net present values, if you just have one cash flow which needs to be evaluated. So you do the same thing if you just are asked to compare a certain cash flow with some given value, for example. So that's the main topics, but now we need to know, when in the upper part we talk about monthly payments. So when does the monthly payment actually happen? And that's the first idea. It could happen at the beginning of the month, so the first day of the month, beginning of the period. Then we talk about a due situation, so like an annuity due. That's a payment happening at the beginning of the month. The opposite, payment taking place at the end of the month, last day of the month, end of the period, that's an annuity immediate. So that's then basically all there is. So first you have to decide what you're actually looking for, what the basic task is all about. Then ask yourself, when does the first payment actually happen? In the beginning or the end of the month? And well, as I said, that's all there is to this topic as well. So this covered the three big parts of business mathematics: the calculus part, the linear algebra part, and the business mathematics part. So I hope that this helps you a little bit better to understand what the different questions are all about, so that you can better answer them accordingly. If you're still looking for some examples to apply this to, you might have a look at the corresponding course or at the corresponding playlist with regard to this session. And well, I hope to see you soon and say goodbye until then.